We've already used the circle in some of the Java FX demos that we've looked at, but now we're going to very carefully go through a circle and something related to it, namely the ellipse. Circle class, of course, defines the circle, and the parameters, as we've already seen, indicate the center x and center y and the radius of the circle. Ellipse is very similar. It also has a center x and center y. However, it has two separate independent radiuses because it turns out that we have an x radius and a y radius. So whereas you'll need 4 parameters to design an ellipse, you only needed 3 in the case of a circle. We'll now look at the UML diagrams for the circle and the ellipse, starting with the circle. You can see we have 3 constructors here. One is a no-arg constructor, which simply creates an empty circle. The second constructor takes 2 doubles, specifying the center of the circle, but does not specify its radius. And finally, the last constructor takes 3 arguments, the xy coordinates of its center plus its radius. The constructors for the ellipse are very similar. We can either create an empty ellipse, an ellipse with a specified xy center, or an ellipse, and this time we have 4 arguments because we have x and y coordinates for the center, but now we have 2 radii, an x radius and a y radius, which can be independently set. When they match, we just have a circle. When they're different, we actually have an ellipse. The main purpose of this demo is to demonstrate the use of the ellipse. But again, I think the author had quite a good time coming up with a creative demo because this is a really good one, I think. And I think you'll enjoy it. So let's start off with the usual things. We have all the imports that we need. We extend the application class. We override the start method. And as you can see, that's what we normally do. And then the stuff on the next couple of lines down here is also what we normally do. Well, up here, I guess we drop something into the scene, in this case an ellipse. Well, my ellipse, it's a special class. We'll get there when the time comes. And then after that, well, we put a title on the stage. We drop the scene into the stage, and then we show the stage. So these are all the things that you're used to. The only line that's special is this line right here, and it's only special because of the particular object that we drop into the scene in this case. As it turns out, that object is called myEclipse, or it's at least a class myEclipse, and you'll see that down here is where this class is defined, and furthermore, and most importantly, it extends pane, so it's a child of pane. In other words, pane is its parent class. It only consists of just a single thing, a private void method called paint, and that's defined in the remainder of what you see in this class. So in other words, myEclipse inherits everything that pane has and merely adds one single extra thing to it, namely a new method called paint. However, it also does 2 other things that are quite noteworthy and important, and that is it overrides 2 of the methods that exist in the pane class. One of them is setWidth that you see here, and there's another override down below of setHeight. Now, when those methods are called, as they will be, we're going to do what the original setWidth and original setHeight did anyway. And you can see that in this next line because we call our superclass, and that would be the regular pane class. We call the setWidth method that's in there. So in other words, so far we haven't done anything new, but then this here is the critical piece right here. So whenever we do a setWidth, we also do a paint. And likewise in the overridden setHeight method, we do the original stuff that we would have always done in the case of setHeight, but then after we're finished it, we do paint. So this paint method is what's defined up here, and that's sort of the meat and potatoes of what happens in this particular program. So let's have a quick look at what paint does. First of all, it clears all the children of the pane. Now the reason that has to happen is because we're going to be painting and repainting this pane every time the window gets resized. And every time that happens, then we're going to start by clearing all the children, and these children are going to be ellipses that we have put into the pane. We're going to clear them all off like they were never there, and then we're going to create 16 new ellipses. We do that in a for loop that you see right here. For I equals 0 to 15 effectively, we're going to go through and do the remaining block of code that you see, which extends from here down to here. What we do in that block in a nutshell is we create an ellipse, and down at the bottom we add that ellipse E1 to our children in the pane. We do this 16 times, we add 16 ellipses. What happens on each iteration is we create a slightly different ellipse. So on every iteration we create an object called E1 of class ellipse, and this is the ellipse that's in JavaFX. So this is, we haven't made up an ellipse class or anything, there is an ellipse class already defined. And then we create that new ellipse with the parameters that you see here. We take the current window width, whatever size that is, or pane width actually, and divide it by 2, and that's going to be the X center of our ellipse. And then we do the same with the height of the pane, and that becomes the Y center. Then we take the width divided by 2 and subtract 50 from it, and that is going to become our X radius, and likewise our Y radius is calculated this time on the basis of the height divided by 2 and subtract 50. So in other words, we're going to make the thing a little bit smaller than the window in each dimension. We then choose random values for red, green, and blue in the color object using the color method. And you'll see that math.random produces a random double in the range of 0 to 1. Well, it just so happens that that is exactly the range of values that are used to represent red, green, and blue. So we do that with red here, green here, and blue here, and effectively we've generated a completely random color. That's going to be the stroke color, or the outline of our ellipse. We then set the fill for our ellipse equal to white, and then we do a rotation on our ellipse, and the rotation we do depends on the value of I. So as we iterate through this loop, I is going from 0 to 15, and what we do is we multiply I by 180 degrees, which would be a half full circle, and then divided by 16, so that we're basically scaling into 16 steps, angles from 0 up to just a little bit less than 0. And what will happen then is every ellipse is rotated slightly more than the previous rather, to give us this nice overlay of rotated ellipses. So this is a very nice, interesting effect to see as we run it. Now before we actually run it, I'd like to just point out why it's important to do things the way the author did them here. It's not the only way to do this, because you saw the binding property before, and how we can bind the the radius or the center, or any parameter to do with the ellipse can be bound to the window length, width and height if we wish. But another way is to do it the way he did it, and that is just to make drawing the ellipse part of what happens when a pane appears. Because every time you change the size of a window, a pane that's in that window is going to also have to be redrawn, and all the stuff that happens within it is going to happen again. So this guarantees that by putting the ellipse as an extension of pane, that as the window changes size, the ellipse will be redrawn, or in this case the ellipses, all 16 of them, will be redrawn appropriately to have the right size and position within that window. So let's go ahead and run this demo now. Okay, so there it is, and this is sort of how it comes up in the default based on what you see over here in the code, where we've got the size of the scene is set to 300 by 200, so 300 pixels this way and 200 pixels this way, and that's what we get. Now of course, even if I don't resize the window and simply rerun the demo, I'm going to probably get different colors, because as you can see there's 16 rotated ellipses here, and they're all of different colors. Now if I make the window smaller, the figure gets smaller, but I'm keeping it proportionally the same, trying to hold the sort of 300 to 200 ratio. But if I don't do that, if I was to make it square, watch what happens. Well, it actually becomes a circle, and now we have 16 circles on top of one another. So basically, the only color you see is the color of the last circle that was drawn. But if I make the window non-square, so that I actually have an ellipse which is longer than it is wide, and therefore as you rotate it, you actually see it in different positions. So I think that's a pretty cool demo. And there we have it. So that's it for our ellipse.